Hello, everybody. My name is Michael Beach. If you're looking for the spelling, it's on your card. Just circle and use it for later. So the title of my talk is Why Study Mars? And there's actually two ideas tied up in there. Study Mars, or what I study on Mars, and why. So first I'm going to tell you about what I study. I study concentric crater fill deposits in the mid-latitudes, which are debris-covered glaciers that fill craters. Now there's some controversy as to the purity of this ice, whether it's a relatively pure ice with debris on top, or if it's sort of a rock glacier with ice in the pore space. But either way, ice is present. And that's unusual because, as we just heard, ice is not really stable in the mid-latitudes on Mars for long periods of time. So at some point in the past, climate must have been different, allowing ice to mobilize from the poles where it's more stable to the mid-latitudes where it then fills craters, and then to become debris covered. Then climate has to change back, so it oscillates. And the ice retreats back up to the poles. And now you have a debris-covered glacier in the mid-latitudes. So we can't actually go take samples, unfortunately. If Congress figures out this sequester thing, maybe we'll go next year. But as for now, we don't have any samples. So I have to look at features on the surface and interpret what was going on both today and in the past. For example, I look at craters, superposed craters, small ones, on the surface of the debris. And if I know the rate of impactors, I can back out the age and understand when climate was different. So now I've told you what I study, but I want to tell you a little bit why. When my friends and family, non-scientists, ask me, Michael, why do you study Mars and climate change? I like to refer back and use the moon as an analogy, specifically the Apollo missions. So the astronauts went all the way to the moon, and they looked back and they saw the Earth for the first time. So they saw the Earth for the first time, their home. Now, some of the most iconic photographs of the Earth from the Apollo era are the Earthrise from Apollo 8 and the blue marble from Apollo 17. So although the moon was the goal, the Earth was in the spotlight. We learned something about ourselves. For example, we went and took samples and brought them back and did chemical analysis. And we found out that the Earth and the moon are not so different. They're very similar. In fact, we had to revise our theories of how the moon formed and how the Earth formed because of what we found. Similarly, when I look at Mars and I study it, I find something about the atmosphere. For example, it's much thinner, and Mars is much colder. And if we go to Venus and study Venus, the atmosphere is much thicker, and it's much warmer. So it's sort of the Goldilocks paradigm. It's too cold, it's too warm, it's just right. So we learn something about our own atmosphere and our own climate. So when we go to other planets and other bodies and study them, we don't just learn about the bodies. We learn about our planet. We learn about ourselves, and we learn about our place in the universe. And that is why I study Mars. Thank you.